Our most dependable constant in the world of physics is the speed of light. But what we've now argued is that this constant says little about the velocity of the particle. It only describes the distance the photon will travel in a given moment of time. The actual velocity of each particle would be relative to its size. Now, back to Bell's theorem, and the need for that orderly, underlying, fundamental structure as the basis to our material universe. As a reminder, his theorem proved that without this consistency, without the supreme balance required to underpin everything, then our material universe would be entirely chaotic. And it's not chaotic, it's supremely structured. Let's now assume that this magnetic field is responsible for this symmetry, the very structure and the fabric supporting our material universe. This perfectly symmetrical toroidal structure reaches through a vast but finite reach of space to define our universal boundary. It is the dynamic scaffold that lies behind all that is manifest. Let's, for the purposes of this argument, call it the Higgs field. We don't know what caused that singularity, that Big Bang, but we do know that somehow matter materialized out of the vacuum. What would happen if one of those strings were disturbed, or perhaps a single misplaced dipole, or perhaps God leaned into that toroid and simply snipped one of those strings? If those strings are made of infinitely long dipoles, then their orderliness would be disturbed, and they would tumble out of that coherent structure like water flowing from a tap, and they then become chaotic. Each dipole would lose its velocity and become relatively static, and being static, it would no longer have a velocity or mass that exceeded the field. Therefore, it would be within the boundary constraints of light, and it would be both visible and measurable. The supporting Higgs field would be invisible and would simply bend around those particles. Each particle would then become as big and as hot and as slow out of the field as it was first small and cold and fast inside that field. Perhaps the singularity was simply the passage of those invisible magnetic particles entering into our own newly created, newly emergent, more familiar dimensions. It would then seem to be manifest as a nebula. We've proposed that the nebula is made up of a huge number of chaotic dipoles that have been ejected from the field. These are the truths, and their size has somehow put them out of reach of the field itself. We now propose that these truths gradually restructure to find orbital associations that reflect that immutable imperative to move towards charge balance. Whatever caused that singularity, they're no longer able to spin. They're suspended in space, and each truth is now as big and as slow and as hot as it was previously, small and cold and fast. And the question now is, what would those chaotic truths do in response to the required immutable principle of charge balance? Always assuming a mass-energy equivalence, one fluid would explode into the nebula with a force equal to the force with which it was expelled. Having reached that size, it would then systematically dissipate that force, to again become small and fast and cold. Eventually it would reach the same size as the dipoles in the field, that boundary constraint. It could now interact with the field. If, at the point of interaction, it presented a light charge, then it may again be repelled to become smaller and colder and faster even than the field dipole, which would make it a quark. And the quark would also and correspondingly be out of touch with the field. Or it may again become big, which would make it a truant. It would therefore oscillate between these two potentials. What it needs to again be stressed is that the particle is discontinuous. It moves in and out of our time dimensions. When it's big, it can't interact with the field. When it's small, it can. And effectively, therefore, Unless the truant or that quark has something with which it can interact, another dipole, then it will appear and disappear, materialize and dematerialize, exactly in the same way as do virtual particles. If two truants formed a composite, then the result would be this. They would dissipate the energy from their field expulsion and decay to a velocity size that is consistent with the Higgs field. When they were again within the boundary constraints of the field, in touch, so to speak, the field would again repel that composite. The truant would be attracted and become bigger, the other would be repelled and become smaller, making a truant-quark association. Both truants would again be out of touch with the Higgs field. Then that oscillation would be repeated. The result would be that the bigger truant would only come into view when it increased in size. It would then flicker out of view, and so on, as does light. Being a composite of two dipoles, it would be neutral. Therefore, it would find the neutral path across that field, which would then radiate outwards from a source in a straight line, all of which are consistent with the properties of a photon. If we're to argue that a composite of two magnetic dipoles form a photon, then we still have to address the question as to their velocity as this relates to its size. How is it that the bigger photon still covers the same distance as the smaller in the same amount of time? We propose that the Higgs field is structured from the orderly arrangement of strings that are massed or assembled as Faraday's lines of force. This is a dynamic structure that spins at some velocity that relates to but yet exceeds the speed of light. One expelled truant is that big that we can see it flicker as a photon of light. Now, let's assume that the truant becomes 4 times bigger than the field dipole. We're now proposing that the 4 of those field dipoles displace each other's position during the same time that the truant grows to its zenith, to that bigger size. Then, as the truant dissipates that energy, again, it holds its position and simply becomes smaller. And this takes place in the same time that it takes for more field dipoles to again displace each other's dipoles. Therefore, the truant would have moved at exactly half the velocity of the field. Therefore, if the truant, that photon, moves at light speed, then the velocity of the field dipoles would be precisely twice the speed of light, being 2c. And if so, then regardless of the size of the truant or its frequency, it would always move at the speed of light. Its interactive moment with the field dipoles would determine that frequency. And this in turn would depend on the energy imparted into the truant at the moment of its very first expulsion from the field. Therefore, in real time, the particle itself would appear to be discontinuous, which is consistent with the observed properties of the electron and the flicker associated with photons. And just a point to add here, it's important to realize that if the expelled truant was actually smaller than the field dipole, then the frequency or the interactive moments with the field would simply be greater. But the truant itself would be more energetic, possibly even more penetrative, but not visible, which would account for those frequencies that do not fall within our visible spectrum. By proposing this interactive moment, we've also resolved the paradox of the wave-particle duality. Effectively, it's the background field that is arranged in strings, and the particle can only move through space at a moment of interaction with that field, which means that as it moved, it would follow the path of those strings. It's the field that moves as a wave. The particle simply follows the path of that wave. We need to stress this. Our proposals are purely conceptual. We're satisfied that more application is needed to give this full justification, which is outside the scope of this exercise. A composite of 3 truants could also form a stable interaction. We can only speculate on the structural arrangement, but it's safe to say that if two dipoles form a neutral composite, like a photon, then a composite of three would have an imbalanced charge. The proposal is that if one of those particle composites always opposes the other two, then its third charge would, by default, interact directly with the field. This means that not only would it move across the strings, as does a photon, but it would also continually interact with the field itself. If it were contained in a purely magnetic field, such as a bubble chamber, then it would effectively move in a spiral. Again, this is also consistent with all the known properties of the electron. Now, more composites, and they would all subdivide into variations of 1 into virtual particles, 2 would be photons, and 3 would be electrons. Therefore, a composite of 4 would resolve as 2 photons. 5 would possibly resolve as 1 electron and 1 photon. 6 could then become 3 photons or 2 electrons. 7 would become 2 photons and 1 electron, and so on. But when we get to a composite of 9 dipoles, then we've got something that is innately stable. Effectively, it's 3 electrons, and we know that the electron is a stable particle. Again, the precise arrangement of these composites has not been resolved. It's a huge study of itself, but the concepts conform to what is known, to those principles of correspondence. And here we resolve the mass-size ratio of the proton to the electron as follows. If the photon comprises 2 dipoles, then each dipole would be half the size of the photon. We propose that the velocity and mass have an inverse proportional relationship. Therefore, if the photon moves at the speed of light, the dipole would move at 2c. So, if the mass of the photon were given as 1, then the mass of the dipole would be 0.5. If the electron comprises 3 dipoles, as we proposed, then its mass would be 0.5 times 3, which is 1.5. And if the proton comprises 3 electrons, then each electron would comprise 0.5 of the quark. 3 quarks having no volume is 0.5 times 3 is 1.5. 4 times bigger for the orbital zenith of the second truant or the pion is 1.5 times 4 equals 6. And 4 times bigger for the orbital zenith of the third truant or the gluon is 6 times 4 equals 24. The pion and the gluon only have 2 dimensions of volume, as they manifest within the prescribed space, that source structure of the 2-dimensional sphere. Therefore, if 3 gluons having length and breadth is 6.6.3, it comes to 108. If 3 pions having length and breadth is 24 by 24 by 3, it comes to 1728. This gives a mass of 1837.5. We discount 1.5 for the quarks that have neither volume nor mass, giving a total of 1836. And some variation of this number is no doubt required to accommodate the spherical shape of that torus, of the truants, but it's complex. It's a 2-dimensional sphere. This, therefore, resolves the mass-size ratio of the electron and the proton, and it relies on the assumption that both the electron and the proton are stable particles, and that they are formed from a composite of those magnetic dipoles that have been ejected from the Higgs field.